Okay, so moving along, now we're going to work backwards. This example, we're going to write expressions as a single logarithm. So we're seeing the expanded version. Can we put it back together? So for part A, first thing to look for is anything that would represent an exponent. So if you remember, if you've got a log with multiplying a number out front, that's an exponent that's going to go back on with our variable or whatever happens to be right there. Here's a 3 in front of log base 4, so that's an exponent. And then this last one doesn't have a number in front, so we're just going to start with that. So 4 times log base 4 of m is the same thing as log base 4 of m to the 4th power. So this 4 right here came from that 4 out front. Plus, same thing here, that 3 out front is our exponent when we put it back together. So we have log base 4 of n to the 3rd power, and then minus log base 4 of p. Okay, so we took care of any exponents. We do that first. Now, let's just work left to right. Here we have log base 4 of m to the 4th plus log base 4 of n to the 3rd. So if you are adding two logs together, we can compress those with multiplication. So that came out of a product. So we keep our log base 4, and then putting it back together, it's going to be m to the 4th times n to the 3rd power minus log base 4 of p. All right, so now we have subtraction. We have log base 4 of something minus log base 4 of something. So when we put that back together, subtraction is an expanded version of that quotient or the fraction. So we're going to put it back together. We're going to have log base 4 of m to the 4th n cubed over p. And now we have written this expression right here as a single logarithm. Here's the single logarithm, log base 4 of that whole thing. So we're just following the same properties we used in the last example, but just going backwards with them. All right, so part B, we have some natural logarithms. With our natural logarithms, let's look, well, it doesn't matter. Logarithm, natural logarithm, same thing, but look for any exponents first. So I'm going to look for any numbers out in front of your natural logarithm. So that 3 is going to go up there for your exponent. Oh, this one has an exponent. So we're going to rewrite that. We have the natural log of 2 to the 3rd power minus the natural log of 5 to the 2nd power. So if you see, we found our exponents. Those end up out in front of each natural log, and we put them back in their exponent position. Now we notice, all right, we have a natural log of 2 to the 3rd minus a natural log of 5 squared. That subtraction, we can put this back together as a quotient, which will be a fraction. So natural log of whatever is first, 2 to the 3rd will be your numerator. So 2 to the 3rd over 5 squared. And now we have a single logarithm. It's a natural logarithm, but it's a single one. So just to simplify this, we can go ahead and cube the 2 and square the 5. So we have natural log of 2 to the 3rd is 8 over 5 squared is 25. And that will be our final answer on that one.